happy return to, I guess this is part number 2 for these equivalent trigonometric functions. So part 1, I've talked about kind of 3 different things, and I'll put up a link to part 1. You can watch that one if you like. In this video, what we're going to talk about is complementary functions for these trigonometric ones, or just cofunctions. And that's going to be mapped out to this unit circle. And then the second thing that we're going to try to do the equivalent trigonometric functions is for these principal angled. So there's heavily reliance on the unit circle here and your understanding of it. And if you do understand the unit circle relatively well, then trying to remember these equivalent trigonometric functions is not going to be as bad. But if you're not comfortable with the unit circle, unfortunately, you might have to brush up on that to really understand these. So I'm going to start with the first one, so the complementary functions. And within here, so let's first kind of define the complementary angle with this triangle that we see on this unit circle. So it is a unit circle, so the hypotenuse is 1. And now if we wanted to find, so if we have this theta, that interior angle, so that acute one, the complement of it is kind of right here. So I'm going to do the complement right there for that. And we know, because of the 90-degree angle that we have within this triangle, and we know that they sum up to 180 in total, that means this one has to be 90 degrees minus that theta, or if you write it in radians, it would have been pi over 2 over theta. All right. So what we want to be able to do is the following. So that's the first thing. So these complementary ones. If we would take the sine of theta, which we know, okay, so that on the unit circle, so really the result is, is just this, right? So it is the opposite over hypotenuse. But the hypotenuse is equal to just 1. So, that's what sine of theta would have been measuring. Now, if we want to compare it to the complement, so this is equal to, now if I look at the complement, so that angle, which is pi over 2 minus the theta, right? So notice that if I take the cos of that angle, so if I take the cos of that angle, which would have been pi over 2 minus theta, all right, it's also going to be that highlighted yellow piece, because cos is adjacent, right? But in this case, that complement is that 90 minus the theta. So the adjacent is actually that yellow piece that we see. So this is the first equivalence for these cofunctions, meaning that sine theta, or sine of x, if you were doing it as a function, is equal to cos of pi over 2 minus x, or minus theta in this case. Now, of course, this, is the same thing, if you recall. So if I take this out, if I take the negative out, so what I'm going to get is just this, all right? And because cos is an even function, because of that, and that was in part 1, then this is just equal to this, right? And that we actually shown in part 1. So if you write it like this, or if you write it like that, then that's fine. All right, within here. So that's the first complement. Now, what if, let me kind of remove, that highlighted piece there. What if instead, I wanted to know what the cos theta, is. So what's the equivalent to that? Well, cos theta is going to be this piece right here, right? Because that's just adjacent. So if I look at the complement of this, so if I want to take the sine, right, because it's going to be the opposite, so that's going to be just, again, so pi over 2 minus the theta, and that is your second cofunction that we have. So sine theta is just equal to cos pi over 2 minus theta, and then cosine is sine of pi over 2 minus theta. So those are the kind of complementary angled equivalences. And because of that, you can also do the same thing. So you can say the tangent of theta, which really is just sine theta over cos theta, right? So that's going to be, now if you do this, then this is going to turn out to be cotangent, of pi over 2 minus the theta, right? So that's what we would have had in here if we wanted to be able to do that. Okay, so nothing special really, okay, with regards to this first piece that we have. Okay, so those are my complementary or co-functions. All right, so we're back with this unit circle, and we're going to do the principal angle, and I'm going to do it kind of quadrant by quadrant, and how we can come up with equivalences with these trigonometric functions if you ever were trying to do it. So within here, I'm going to first try to compare and do equivalences between the first quadrant and then the second quadrant. So what if I took the same angle, right? So this is my principal angle. I'm going to duplicate this. And what I'm going to do is I'm going to shift it over, so onto this side. So we want it like this. And okay, let me just make it so that it is kind of equivalent here. There we go. So this is my, okay, so this is the same angle right here. So I want to be able to compare, okay, so this is my quadrant number 2. Now, what do I know about quadrant number 2? So if you remember when I did the unit circle and I presented it, okay, both the cos and the sine, okay, because they're just x and y values of the unit circle, were positive in the first quadrant. In the second quadrant, well, we have that our x, okay, in this case the cos, would have been negative, and then the sine would have still been positive, right? So this is what I have there. So if I want to compare right here, so for instance, if I want to take the sine of, okay, that angle, which is really pi, right? So if I take the entire thing, so pi is 180, and then minus the theta, so I am looking at this angle right here, so going from here to here, right? So I'm going at that angle. Now I want to compare it, okay? I want to compare this particular result, right? So pi minus the theta. I want to compare it to the equivalence in the first quadrant. So what is that equal to? Well, as you can see in this case, the sines of these, okay, and the sines are the y values, they're both positive here. So the first equivalence between these two is that sine of pi minus theta, or x if you were using it as a function or something, but I guess we can use theta in terms of a function of theta. So sine pi minus theta is equal to just sine of theta, right? And that again just goes back to that unit circle. So these two are equivalent, and as you can see, they would be equivalent because it is just the height, because that's what the sine of theta is, and then here it would have been the height of that. Well, these two are equivalent, so these two heights are actually equivalent. Now, what if I wanted to find the second equivalence between cos of that particular angle, so pi minus the theta? Well, cos is different, right? Because cos now, notice, that's going to be, okay, so these, comparison to these, well, notice one is positive, one is negative. So cos of pi minus theta is going to be equal to, well, the negative of cos theta, right? Because cos theta is positive, but now if you flip it over, it's going to become negative. So that would have been, okay, so within here, so cos would have been this distance, okay, so about there, but on this side, it's going to be this distance, well, which is in the negative side of x. So that's what we would have had there. Now, the third one, so now if you wanted to really complicate things and say, okay, what about tan? So tangent of theta minus the pi, so in that quadrant, so what would that equal? Well, that's just sine over cos, right? So sine over cos, notice if I take a look at this, well, one is positive, one is negative. So this is going to be equal to negative tan of theta. And I'm just taking it from utilizing these right here. Okay, so this is positive, and then this one is negative. So if you put one over the other, okay, it's going to make the tangent negative. So that's comparison of the principal angle to the second quadrant. Now we can continue this, right? What we can do is we can take this and we can do the third quadrant. So I mean, I can do now this, right? So it's going to be somewhere over there, okay? And so now this is now my theta right here, and instead, you know, what I am talking about, okay, my angle, my new angle is going to be this whole thing. So if I want to now, this is for the third quadrant. And in the third quadrant, I know that both the x and the y are negative. So meaning the cos and the sine are both negative. So if I want to compare here, and I want to say, oh, okay, so what is sine? Now notice that angle is going to be pi plus theta. So what is that going to be equivalent to if I compared it to the first quadrant? Well, in this case, notice that the sine is actually negative, right? So this is going to be equivalent to negative of sine of theta. And now for the cos, so if you take cos of pi plus the theta, well, the cos is also negative. So this is going to be negative of cos theta. Now for the tangent, okay, so now this is interesting because, well, both of these are negative. Well, so a negative over a negative is actually positive. So this is going to be equivalent to this. So I'm using the unit circle to come up with these equivalencies, right? And you can do that, and you can try to, you know, kind of understand the unit circle and map it out in this way. It's not easy to memorize these. Like if I see something like this, I do actually, you know, my brain can't memorize all of these. And if you looked at the video of part 1, I mean, there are many different things, right? So you need to create kind of these tools, okay, these memory tools. So I use the unit circle to remember. So if I'm working on these, and if it's a chapter that I have to do, or even if I have to teach it, you know, don't think that I just know this right off the bat. I just use patterns of things that I've known before. So I've learned the unit circle very well. I understand the quadrants when they're positive and negative. I relate it back to cos and sine. And then I use that to my advantage. Okay? So now in the fourth quadrant, I can of course take this and swing it all the way over here. So that would have been 2 pi, right? So 2 pi, because we're going 2 pi minus the theta. So this would have been minus the theta, so 2 pi minus the theta. Or you can just simply say minus theta, right? Because these two are equivalent in terms of the angle. So one or the other. Okay, so I'll just do one of them. So notice that in this quadrant, so what do we have? Our x is positive, so that's my cos. My y is negative, so that's my sine. That's in that particular quadrant. So if I wanted to, for instance, do, you know, sine of 2 pi, I guess, minus theta, or just simply this is equal to sine of minus theta, right? Okay, so what do I know in that quadrant? Well, in that quadrant, I know that the sine is negative, right? And in the first quadrant, okay, so what that would mean, this is going to be negative of sine of theta. And you can do the same thing for cos. So cos 2 pi minus theta, or just cos minus theta, is going to be cos of theta, because in that quadrant, the x is actually also positive, all right? So that's one way of learning these principal angled and then combining them, okay, to see equivalences between one and the other. Equivalence just means equal. What is it equal to with respect to that first quadrant, that original sine? Because if you're graphing the functions, it's very easy to do sine theta or, you know, negative cos theta, right, which is just a reflection, and so on. So here's the summary. You know, I kind of wrote it down before. So here are all the quadrants that we have. Okay. And notice that, you know, the key thing here is, notice what I'm using. And this is what I actually used. Okay. So notice that these were, so again, this is the x and the y. Or you can remember this is the cos. This is the sine. Right. And then you can see that it aligns exactly with the actual. Okay, so sine, notice that it's positive, cos is negative in the second quadrant, so that means one over the other is still going to be negative. Here, both of them are negative, so hence negative, negative. Okay, this becomes positive because the negative divided by a negative. And in the fourth quadrant, so again, so this is positive and negative. So my cos is positive, my sine is negative. And then if you do one over the other, it will be negative as well. And then those are the equivalences. But that's a ton of stuff to remember. So I feel for you if you have to go through this on your own. I tried to present it to you. You know, you can set up your notes. You can take my notes here, screenshot them for yourself. But it's not certainly something very easy to remember. So don't feel bad. And then try to find these mnemonics. Okay, so these tools to remember. I use the unit circle heavily, right? Notice for this to really understand it. And then for this one, you know, I just plotted it on the unit circle for the co-functions or complementary to be able to see. Okay, these ones are hopefully not as bad. Okay, so thank you for watching. So that's part 2 that kind of combines part 1 and part 2 together to give you a sense of like how can you go about with these trig items to remember the equivalences. Okay, so that's you know, one way. Okay, more to come in future videos. Okay, thank you for watching. Take care of yourself. Bye, everybody. Cheers.